Okay, here's part 2 when we're talking about some special cases. Now, if you look at both of these equations, neither one is in slope-intercept form, so we're going to have to solve for y. Subtract 2x from each side. So I have y is equal to negative 2x plus 5. When I go to graph that, I'm going to start at my y-intercept. 1, 2, 3, 4, 5. And I'm going to use my slope of negative 2 down 2 over 1, down 2 over 1, down 2 over 1. Once I have enough dots, I'll use my straight edge to connect them. Remember, it's so important to use a straight edge because with solving systems of graphing, you need to make sure that you have accurate graphs. Okay, equation number 2 also has a 2x. So I'm a little suspicious because I'm doing the same thing twice when I go to solve for y. So y is equal to negative 2x plus 1. Here's my b, so I'm going to come up 1, starting from the origin, count up 1, and I use my same slope, down 2 over 1, down 2 over 1, down 2 over 1, and I'm beginning to realize that they're never going to cross because when I draw these lines, I end up with 2 parallel lines. And I remember the fact that parallel lines have the same slope. And I knew that from our last unit. But now let's talk about what that means now. They will never intersect. This line is going to continue forever and ever at a rate of negative 2. So will this one. Therefore, my solution is the empty set, or none, because they're never going to cross. Remember, your solution is the point where they crisscross, and that's never going to happen. Okay, let's look at our next special case for number 8. So now I'm suspicious. What do they mean by special cases? Let's go ahead and take a look at this next line. Again, I can't graph until I solve for y. This 2x is negative, so I'm going to be adding 2x to each side. Y is equal to 2x plus 3. Here's my b, so I'm going to count from 0. 1, 2, 3. Keep in mind, the reason why we start with that is because as the y-intercept, that means when x is equal to 0, if I put a 0 in here, I get an output of 3 over 0 up 1, 2, 3. My slope is equal to positive 2, rise 2, run 1, rise 2, run 1, or I could fall 2, go back 1, fall 2, go back 1. So this line here represents this first equation. All right, so I'll go ahead and look at my second line. I have to solve for y. This one's a little more complicated. I'll add 4x to each side. My 2y is equal to 4x plus 6. These are not like terms. I can't add them, so I just list them. I don't want 2 y's, I want 1 y. So I'm going to go ahead and divide everything by 2. Y is equal to 2x plus 3. Uh-oh. Check it out. it feels the same. When I graph my intercept of 3 and I count rise 2, run 1, rise 2, run 1, I notice that I'm drawing my lines on the same exact lines that were there before. Because they have the same slope, because they have the same y-intercept, that means that they are the same line. So here's the deal. When we have two lines that are the same line, we have a special name for them. They are coincident. Coincident. In fact, we say, hey, what a coincidence, we're the same line. When I'm looking for my solution, all real numbers. That means that every single thing is going to match up. When I put it in set builder notation, I can go ahead and say everything that the solutions are then going to be all real numbers because they are the same lines. There are infinite solutions. Okay, let's check out numbers 9 and 10. The system of linear equations is graphed as shown. What is the solution? So this is a quick and easy question because when I'm looking for my solution to my linear system, boom, right where they crisscross. This is going to be the point, and remember it's an xy that is true for both. So when I count over 1, 2, 3 and up 1, 2, 3, 4, my solution is going to be 3, 4. Alright, so here's a fun application question. We bought 12 bottles of apple and orange juice for a school dance. The apple juice was on sale for $1 per bottle. The orange juice was $2 per bottle. I spent $16. Write an algebraic model. So whenever we're solving a system, remember we're looking for two relationships because we're looking for where they intersect. So I'm going to let x equal to the number of apple juice bottles that I buy, and I'm going to let y equal to the number of orange juice bottles that I buy. This first sentence here, I bought 12 bottles of apple and orange juice, is my first relationship. X plus y is equal to 12. That first one is going to be about my numbers or my amounts of things that I bought. My next relationship that I'm going to look for is this story here, and this has to do with dollars. $1, $2, depending on which kind I buy. So if it's $1 for every apple juice and $2 for every orange juice, and I spent $16, there I have my relationship. Both of these equations worked out to be in standard form. So I'm going to put them into y-intercept form, slope-intercept form, and solve for y. Minus x plus 12. And 2y is equal to negative x, because I'm going to subtract x from each side. Plus 16, divide by 2, divide by 2, divide by 2. Y is equal to negative 1/2 x plus 8. Okay, so let's graph this one first. The y-intercept of 12, which means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then I can go ahead and count down at a slope of negative 1. Fall 1, run 1, fall 1, run 1. And I know that, and I want to be real careful to make sure I line up my straight edge, that I'm going straight through those lines. Remember, when you're graphing to solve a system of equations, You need to be super good at your graphs. Right here I have a y-intercept of 8. And my slope is now going to be -1/2. Down 1 over 2. Down 1 over 2. Down 1 over 2. Down 1 over 2. This looks like it's going to be my solution. Remember, I kept counting until I found a point that they shared. That shared point is going to be the solution of my graph. So in order for me to understand what I'm talking about here, I need to take the time to look at what each of these axes represents. Do you remember X was my number of apple juice bottles that I bought? That's going to be my X axis. And do you remember Y was my number of orange juice bottles that I bought? Orange. So here's my orange juice. So when I look at this answer here, I know that it's 8 apple juices and 4 orange juices. So when I answer a word problem or an application problem, you should do it in a full sentence. So you can say, therefore, you bought 8 apple and 4 orange juice bottles. All right, good job. Keep up the good work. Keep graphing.